Hello. Today we're going to talk about Topic 3, Section 8, trig ratios beyond acute angles. Okay, so usually we talk about our angles between 0 and 90 degrees or pi over 2 radians. That's usually our reference, right? When we start with the point 1, 0, if we have a positive angle, we would go in this direction. All right, so that's if you have a positive angle. And then if you have a negative angle, you measure from this direction. Okay, so we always start off of the x-axis, okay, at the point 1, 0. Okay, so here you just want to be able to identify things off of your, your base angles, cosine 57 and sine 57. So we start by drawing an angle of 57 degrees. That's almost 2/3. Okay, so we're going to say this is 57 degrees, right, in the positive direction. And because again, we're going that direction. And here we're at this point, and you should know that it's cosine comma sine. So cosine is 0.545 here, and it's up here, and sine 57 is 0.839. Again, always remember it alphabetical. Okay, x comma y, c comma s, cosine comma sine. All right, so here we have this point, so we will label this point A. Then we want to draw an inscribed rectangle in the unit circle. All right, parallel with the x and y axis. So this was A. Here, if I hopefully have enough colors. All right, so parallel with the x and y axes. All right, so here, use the symmetry of the rectangle to identify the coordinates of the other vertices. So here, we know the height is going to be the same over here. So this is going to be 0.839. The y value is the same as this one. And since this is a rectangle, the y-axis is cutting it down the middle. Okay, and so this went positive 0.545. This will be negative 0.545. Then this x value would be the same. Now the y value, we go halfway is to the x-axis, then we go another half. That would be negative 0.839. Here we have positive x-axis, so 0.545, comma, negative 0.839, because it's in the negative y direction. Okay, so use the symmetry of the rectangle to determine the angles for its other vertices. Okay, so here we want to label the angles. So let me use green. Okay, so determine the angles. So think of this as a mirror image. So if I were to draw this, this is supposed to mirror that red line, which means this angle is 57, which means this angle, okay, is 180 minus 57. So the angle for this one, I think they labeled it E, okay, for point E, is going to be 123 degrees. So at for E, it's at angle 123 degrees because you label it from this x-axis, from 0, 1. I'm sorry, 1, 0. Okay, then we can do, all right, sorry about that. That was my sister. All right, so the next one is the next angle. Let's see, they labeled it, what did they label it, all E? Oh, no, F. There was just a typo. Okay, sorry. All right, so this one was F. So if you mirror this angle down here, this is 57 degrees. So then if you think, okay, I've got to go all the way 180 plus 57. Okay, so to get to point F, that reference angle would be considered, why can't I think? 180 plus 57 is 237. There we go. All right, so then we have the next angle. Oh, I'm running out of colors. I guess pink. So we go down here. They labeled this one D. And to get here, we go 180. Oh, I'm covering up the purple. Hold on. So we go 180 plus the 90 plus a little amount. But think about it. This angle right here should be 57, right? Because think of it, a mirror image. It's folding down over the x-axis. All right, so this is 57. So I like to think of it as 360 minus 57. So that's 303 to get to point D. And then if we just asked simply what's the cosine of 123 degrees, well here we just go to that angle, 123 degrees, and the cosine is negative 0.545, and the sine is just the y value. Then F, the sine is the x value, the sine is the y value, and we just keep on rolling. Okay, and so then you notice the relationships. Okay, that sine is positive in the first two quadrants, and that cosine is positive in the first and the fourth quadrant. Okay, all right, it's important to know those things. All right, so here we're just making connections between the angles and our reference angle. So here I'm going to call this P and then label these A, B, C, D. I think that's just going to be easier to see. So for starters, let's do A. So we're going to do pi minus the angle. Well, pi, remember the whole thing is 2 pi, so right here would be pi. So I'm going to do the 180 degrees minus this distance. So we put that over here. So that distance, that should be point A. All right. Then we're going to do 2 pi minus the angle. So 2 pi is the entire circle, so 2 pi ends up being here, minus that reference angle would be about here. Then C is pi plus theta. So we're going to go the entire pi, so 180, add the angle. It's about here. Then D is the angle plus 2 pi. So 2 pi, we should know what that is. That's the entire circle. We made one entire loop, and then we add the angle. So here, we end up being the same thing. So these being equal. Okay, I guess I should write that a little better. Equals. All right. All right, so for these, I like to visualize things. So imagine my x and y axis, and let's do the original angle. So my alpha, and I know that the sine of that angle is 3 over 5. So sine, remember SOHCAHTOA, opposite over hypotenuse, so that means this is 3 and this is 5. Okay, and then if I can do the Pythagorean theorem, and I should know that this is a 3, 4, 5. So then I like to visualize. So now let's do A. Well, that's pi minus the angle. 180 minus that angle. So we're going to go up the 3 amount, 4, 5, okay? And then I know I'm doing the sine of that angle. Well, sine, this is where you want to remember your shortcut. All, oh, I'm sorry, not all. A, smart, trig, class. And that means everything's positive, or all things are positive in the first quadrant. Only sine and sine is positive in the second quadrant. Trig means tangent is positive. And the fourth quadrant, only cosine. Okay? So here, if we're in the second quadrant, A smart, so sine is positive, so we know that the sine is still 3/5 positive, 3/5. Okay? Let me show you again. So let's do the second one, B. Pi plus the angle. So 180 plus the angle. We're now down here, trig. So only tangent is positive, so that means sine is negative 3/5. Okay? And then here, for part C, 2 pi minus theta, we're down here. So cosine is positive, so that means sine is negative. All right, let's do example number 5. Okay, so sine is 2/7. I like to draw this. So, well, I'll start with red. That's what I did in the last one. So let's see. We know sine is opposite over hypotenuse. We can figure out the other side. So Pythagorean theorem. So 49 equals 4 plus, that would be our x squared. So this is the square root of 45. And this is our x, our angle. Okay, so we want to find cosine of that angle. So cosine is adjacent over hypotenuse. So cosine would just end up being the square root of 45 over 7. Hopefully you know that square root of 45 simplifies to 3 square roots of 5 over 7. Next one, we do 3 pi plus the angle. So our angle is, let me change my color. All right, so x is this part. So we want to add 3 pi. Well, 2 pi gets me back at the starter. Another pi gets me here. And I want to add that x. Okay, so I'm down here. So I want to be cosine over here. So remember, A smart trig class, only trig. So only tangent's positive. So that means cosine has to be negative that value. Okay, it helps to know your reference angles. All right, let's do another example. So here we have the angle has to be between 0 and pi over 2. So in the first quadrant, make sure you understand what that means here. So sine of that angle is 1/2, so opposite over hypotenuse. Do the Pythagorean theorem here. You would get the square root of 3. So what is the tangent? The tangent must be opposite over adjacent. So that's 1 over the square root of 3. So we rationalize that. There we go. Then the next one, part B, 180 minus the angle. So think about it, we're over here. A smart, so only sine, so tangent is negative. C, add 180 to my angle, so I'm here. Add my angle. trig class. So trig is positive tangent. Okay? I think it's helpful to draw these out and visualize it. Okay? That's your best way to go about these problems. Just put your pen to paper and try something. All right, so for these, all right, you can think about sine and separate it as sine of 6 pi over 6 plus 1 pi over 6. Why would I do that? Because that's just sine of pi plus pi over 6. And we can do each of these individually. So think about what sine of pi over 6 is. Hopefully we remember that sine of pi over 6. We do the hand trick and we get 1/2. Well, visualize it. You're over here. We want to add pi to it. So we're now here. Add the angle. So the sine is now negative. A smart trig class. So only tangent's positive. So this one has to be negative 1/2. Okay, let me try and walk you through that again. So here, tangent, we can do the same thing. 6 pi over 6 plus 1 pi over 6. We do that. Ooh, just copying it over. Tangent of pi plus pi over 6. We do those separately. Sorry, my mind is going off like crazy. Okay, so do tangent of pi over 6. All right, let's see. That is 1/2 over the square root of 3 over 2. That's 1 over the square root of 3, square root of 3 over 3. Ooh, that's a terrible 3. All right, then think about it. We're doing the same thing as we did up there. We were normally here, but we want to add 180 degrees, so now we're down here. Tangent's positive there, so we leave it positive. All right, let's do another one. So cosine, I would do 3 pi over 3 plus 2 pi over 3. So again, that's just cosine of pi plus 2 pi over 3. We could do it with subtraction, but I think it's easier as addition, okay? Just visually is easier for me. So let's think about what cosine of 2 pi over 3 is. So ooh, that one ends up being in the second quadrant anyway, so we have to do that one as subtraction. All right, I tried. Okay, so let me erase that. Okay, so for this one, it's easier to have a 1. Like, see how we have a 1 here? So I'm going to make that 6 pi over 3 minus 1 pi over 3. And that's going to be easier. Okay, yeah, I think addition's easier too, but yep, we really need that 1 to make the graph a lot easier. So here we get 2 pi minus pi over 3. So hopefully we remember that cosine pi over 3 is 1/2. Yes. And visualize it. Our angle is, well, 2 pi minus the angle. So the normal pi over 3 is there. 2 pi minus that is now in the fourth quadrant. So a smart trig class is positive cosine, so 1/2. All right, hopefully this is making sense. Okay, so explaining the ambiguous case of the sine rule. So what happens? You're like, this looks like a perfectly normal triangle, okay? However, this isn't the only type of triangle I could draw with this information. All right, instead of drawing this angle and having this side, I could swing this side right here, 7, out. Okay? So instead of having it go in towards A, I could push it out, okay, away. And notice it's the same length, but I get two very different triangles. A smaller one, but with an obtuse angle, and a bigger one with acute angles. Okay, so that's the ambiguous case. And you're probably thinking, okay, well, when does that happen? How do I know to look out for that? Okay, well, there is a clear-cut way. Okay, notice I have an angle, a side, and a side. So remember, side, angle, side angle, all that good stuff. Remember this. No bad words in geometry, okay? Think about it, go in the other direction, right? That's the only way I know. It's bad, I hate it, but that's the way you can remember it, okay? So when you're given just this information, danger, okay? Interesting, weird things happen, okay? So here we can simply solve, okay, so for this first triangle, we can find angle B by simply doing the law of sines, right? 7 over sine 30 must equal 12 over sine B. Let me get my calculator. So here, solving this ratio, you should be doing, let's see, would that be 12 times sine 30 and then divided by 7. All right, so you should get that, and then you do the inverse sine of that answer, and you get this. However, look at that answer. Does that look like 58.9 degrees? Remember what I said. One triangle would be small and have an obtuse angle. The other one would be larger and have a smaller one. So actually what this solved for was for the B prime, the smaller one. So this was 59 degrees, okay, roughly rounded, okay? So you're probably thinking, well, how do I get the other one? Okay, well, think about what you made here. This triangle is isosceles. So if this is 59 degrees, then this has to be 59. So then all we have to do is do 180 minus 59, and that gives us 121 degrees. So that's how we can find the angles of the ambiguous case. So this was kind of neat. This section showed you how they got the Pythagorean identity with trig. So you can always derive it yourself. So they converted this around, let's see, c squared. Oh, okay. I don't know why they did this and didn't make that the hypotenuse, but whatever, we'll follow it along. So here we can divide by b squared everything. Okay, that equals 1. Then we kind of take out the squared, so think of it like this. All right, and then think about what that ratio of c over b. So here, I'm going to use my angle A. This is my angle, my reference angle, whatever you want to think about it as. So C is my adjacent, B is my hypotenuse, A is my opposite. So here we had C over B. So that is adjacent over hypotenuse, which is cosine. Okay, so we know cosine of angle A is C over B. A over B, opposite over hypotenuse, is sine. Okay, SOHCAHTOA. So that's sine of A. Okay, and then another way to write that is, of course, cosine squared plus sine squared equals 1. Okay, and that's what's kind of neat about this. Okay, All right, recognize the difference between when I squared everything, the entire cosine, and putting a squared there. That this error is telling you to be careful of cosine a squared. Because when I say cosine a squared, that's assuming you're writing it like this. Okay, be very careful. All right, so here I would encourage you to use the equation we just did, that trig ratio, or trig identity, sorry, Pythagorean identity. So here we know that cosine squared plus sine squared equals 1. Well, theta, alpha, it's all the same. So if sine is 1/3, then I can just do 1/3 squared and solve this. So then I get cosine squared. I'm going to skip a step here. 1/3 squared is 1/9. Subtract it from the other side. I get 8/9. And then here, I'm going to take the square root. Hopefully you remember this. All right, I say this all the time. When you put the square root there, you have to put plus or minus. Okay? So cosine theta must equal plus or minus the square root of 8/9. So we simplify that to plus or minus, let's see, 2 squared root of 2/3. So we have two possible solutions here. That's why I wouldn't always necessarily draw a reference angle, because you might be leaving something out. Cosine could also be negative if sine is positive. Think about it in the first and second quadrant. Okay? Sine is positive here and here. However, cosine is positive and negative. So it could be either one. All right, we don't know. All right, so let's keep rolling. Let's do number 2. So let's see. All right, so for this one, we want to solve it by graphing. So you want to get out your graphing calculator, clear all that out. Okay, so here we want these equations, or both the left and the right side, to be equal. So I'm just going to plug in each side. So 3 cosine theta, and, or I'm sorry, cosine x, and then tangent x for the other equation, and then I'm going to see where they intersect. Okay, that's my goal here. Now, you want to make sure that you are in radians. Why is that? Because that is what they said, 0 to 2 pi. If we wanted it in degrees, they would say 360. So then I'm going to adjust the window, and let's see, my x needs to go from 0 to 2 pi. So where's my pi? Second caret. And let's do it every, I don't know, pi over 4. Sure. Those are my tick marks. Okay. Then let's see. My y's, I'm going to have it go from -4 to 4. All right, remember that's my tangent. Next one is my cosine, and I'm looking for where they intersect, and it looks like I have 2 points of intersection. Okay, so I have 1 point right here and another point right here. So then I'm going to do my second trace and do intersect. So since I'm right here, I'm just going to do this one. All right, my second curve, close enough. Good enough for me. All right, the intersection is this. Let me double check on Cognitive. What is that? 2.13 comma -1.59. Perfect. Then I do second trace and do intersect again. And I just keep going to the left, and you'll see it hop over. There you go. Good enough. Good enough. and there is our second point. So the point above the x-axis, okay, would be 1.01, comma 1.59, and the other point would be 2.13, comma negative 1.59. All right, but I don't need both of those, all that information. That's way too much. Okay, so think to yourself, there are no y's. All right, that's because you were looking for when the y's equaled each other. So we don't care about the y's. My solution would be 1.01 and 2.13. That's what you would give people. Okay, so that's your solution there. All right, hopefully that makes sense. All right, so here we can keep going. We can do the same thing. All right, plug this in as your y1 equation, plug the second side, the right side, as your second equation, and then look for the intersection. A couple things you want to make sure you look out for is adjust window. Okay, usually they tell you, all right, what you want to keep in mind. The second thing you want to also make sure is check your mode. That's supposed to be an M. All right, so whether it's degrees or radians. So here on our calculator, we're going to go to y equals, clear both of them. Okay, so we have 5 sine of 2x. I gotta do it this way, I guess. Yeah. All right, let me change it. So insert, I just like to be safe, put parentheses. Dang it, it's supposed to be 5 parentheses. Sine squared. Okay, that's the first one. And the next one is 4 times cosine x minus 1 squared. Okay, then check our window. Our x is going from negative pi over 2 to pi, oh, no, pi over 2. I think that was pi over 4. That's fine by me. And let's see, the highest it's going to get, the highest sine and cosine can ever get is 1, so that's 4 and 5. So let's go to negative 6 to 6. There's my sine graph. And there's my cosine graph. So here, it looks like it has 4 points of intersection. Okay, so the answer should be, once you do all those intersections, you get negative 1.27, negative 0.176, 0.424, and 1.02. Okay, those are all your values. Okay, you do the same thing for here, and let's see, when you graph that, you should get 4 solutions. Okay, and that's all it was looking for, 4 points. Okay, think of it like that, as 4 points of intersection. Okay, I think you got it from here, but if you want me to do that in class, just holler at me. I'll be happy to help you out. I'm just tired. Okay, all right. Let's see, that's the end of this, so you should know all this by the end of this lesson. If you have any questions, feel free to ask.